Hello friends, welcome to the physics class. In last lecture we have seen what is photoelectric effect. If we revise that what is photoelectric effect, we will see if a suitable frequency light incident on a material, specifically a metal bulb, above the threshold frequency, that surface starts to emit electron, and this phenomenon is basically called it as photoelectric effect. If suppose we have a surface like this, if we have a surface and we have a radiation which is hitting over here, when the frequency of this radiation is greater than threshold frequency, that suitable frequency, then and only then electron will start to emit. For a normal frequency which is not suitable for this metal or the substance or the material, then there will be no photoelectric effect. But above a specific frequency, and that suitable frequency is called it as threshold frequency, then what will happen? Electron will start to emit. Electron will be emitted from the surface, and this phenomenon is basically called it as photoelectric effect. But for photoelectric effect, we should have a metal surface, we should have a suitable frequency of the radiation, and that suitable frequency is called it as threshold frequency, and then the surface starts to emit the electron, and this whole process is called photoelectric effect, which we have seen in last lecture. Now, in today's lecture, we will see the experimental study of this photoelectric effect, and this is also called it as Hertz experiment. This is experimental study of photoelectric effect. तो हम इस लेक्चर के अंदर एक्सपेरिमेंटल प्रूफ देखेंगे फोटोइलेक्ट्रिक इफेक्ट का कि एक्सपेरिमेंटली कैसे फोटोइलेक्ट्रिक इफेक्ट हो सकता है. And for that we should understand one diagram which is very important. If we understood that diagram, then we are able to understand experimental study of the photoelectric effect. But before this lecture, if you haven't seen the previous lecture which is on photoelectric effect, then you have to watch that video. Then and only then you will be able to understand this lecture. लास्ट लेक्चर में हमने फोटो इलेक्ट्रिक इफेक्ट डिटेल में स्टडी किया है. आपको इस लेक्चर से पहले वो लेक्चर देखना पड़ेगा, तभी आपको ये स्टडी समझ आएगी, एक्सपेरिमेंटल स्टडी ऑफ फोटो इलेक्ट्रिक इफेक्ट. नाउ ऑल ऑफ यू सी द पीपीटी. Okay, now see this. Experimental study of photoelectric effect. Now all of you concentrate on the arrow. Okay. Now if we see this diagram, in here we have a tube, okay, which is evacuated glass or quartz tube. इवैक्यूएटेड ग्लास और क्वार्ट्ज ट्यूब का मतलब क्या है? ये जो ट्यूब है इसके अंदर से पूरी गैस को निकाल दिया है, ठीक है, सक्शन क्रिएट किया है, तो दैट इज इवैक्यूएटेड ग्लास और क्वार्ट्ज ट्यूब. ये होल ट्यूब है. अगर ये आपको डायग्राम नहीं दिख रहा है तो ये नेक्स्ट डायग्राम में आप थोड़ा सा अंडरस्टैंड करें. सी दिस इज टाइप ऑफ शेप. दिस इज द इवैक्यूएटेड चेंबर. इवैक्यूएटेड चेंबर मतलब इसमें से सारी चीजें निकाल दी. सारी चीजें मींस एयर इज रिमूव्ड फ्रॉम दिस चेंबर. देन हियर वी हैव अ विंडो व्हिच इज कॉल्ड इट एज क्वार्ट्ज विंडो. क्वार्ट्ज विंडो हम इसलिए यूज करते हैं क्योंकि बहुत सारे ग्लासेस के अंदर अल्ट्रावायलेट रेस जो है वो मूव नहीं कर पाती है, वो रिफ्लेक्ट बैक करती है. बट व्हेन वी यूज दिस क्वार्ट्ज क्रिस्टल, अल्ट्रावायलेट रेस एंटर टू दैट. In certain classes ultraviolet rays cannot pass. तो यहाँ पे जो विंडो है, ये जो विंडो है आप नेक्स्ट डायग्राम में भी देख सकते हैं. See this window. This window is made up of quartz. Why? Then and only then this ultraviolet rays coming from the sun can enter. Okay, this is the window. If you concentrate on that diagram, you will be able to see that. W is the window, this one, arrow. Okay, see this. Over here, we have a quartz window which allows the ultraviolet rays to move inside. When we move in, this ray moves inside, it hit to this part C, and C is basically called it as emitter, photosensitive plate. In this chapter, we have seen that material or suitable material, that is basically photosensitive material. जो मेटल होते हैं, हमें ऐसा मटेरियल लेना है that should be photosensitive. अगर लाइट से उसको कोई इफेक्ट होता ही नहीं है, तो फिर फोटो इलेक्ट्रिक इफेक्ट होगा क्या? नहीं. फॉर फोटो इलेक्ट्रिक इफेक्ट वी नीड photosensitive plate, and that specifically that is a metal. And this plate, which is called it as photosensitive plate, is made up of metal, and the name is emitter. The name of this plate is emitter. Then movement of electron. This is what movement of electron. Electron will come out from this emitter. According to the name, you can be able to understand that electrons are emitted by this plate. Okay. C stands for cathode. Negative terminal is basically called it as cathode. And A is for anode, positive. Now, this A plate is collector plate. A plate is a collector plate which is positively charged. Then there will be, since here we have a positive charge, here will be negative charge, there will be certain electric field between these two plates, cathode and anode. That is represented by E. There will be movement of electron from emitter to collector plate, means cathode to anode. This is shown by the movement of this electron. Then voltage is provided by this commutator. Okay, here we have very high voltage which is provided across anode and cathode, or collector plate and emitter plate. Then here commutator is used to change the potentials. You can make collector as negative or positive. Similarly, you can make emitter as negative or positive with the help of commutator. Commutator के डायरेक्शन को चेंज करके आप एमिटर और कलेक्टर के पोटेंशियल्स को चेंज कर सकते हैं. There is V is a voltmeter which is across this commutator and the battery. Here is the emitter which is used to measure the current. Here you can change the voltage. This is a variable resistance over here. This is the battery or a cell. Okay. Then now I explain each and every part of this diagram. Okay. Well, first is what? Quartz window, photosensitive plate, electric field, source of light can be sunlight, evacuated glass tube. This whole tube is basically a evacuated glass tube or quartz tube. This is collector plate, this is emitter plate. This is the direction of photocurrent. This one is commutator. This is the direction of movement of electron from emitter to collector, and this. Now we will see the working of this one. Okay, now see over here, first of all, the light will incident, it will pass from the window, quartz window. Then what will happen? Ultraviolet rays will be allowed to move through this quartz window, and they will hit to this photosensitive plate or emitter, and it is also called it as cathode. Then will there be a photoelectric effect? As such, this light incident on the photosensitive material? No. The frequency of this ultraviolet rays or the radiation should be greater than that suitable frequency required by this emitter plate, and that frequency is called it as threshold frequency. तो वो स्पेसिफिक फ्रीक्वेंसी के ऊपर का रेडिएशन जब इमीटर पे हिट करेगा तभी उस प्लेट से इलेक्ट्रॉन जंप होना स्टार्ट करेंगे। उससे पहले कोई भी इलेक्ट्रॉन वहां से जंप आउट नहीं करेंगे इमीटर से। इमीटर से इलेक्ट्रॉन जंप आउट कब स्टार्ट होंगे? जब इंसिडेंट रेडिएशन का फ्रीक्वेंसी इज ग्रेटर देन थ्रेशोल्ड फ्रीक्वेंसी, and when this frequency is greater than threshold frequency, it will start to emit electron, and this is basically called it as photoelectric effect. Now when the frequency of this radiation is greater than threshold frequency or the suitable frequency, emitter plate starts to emit electrons. This whole phenomenon is called photoelectric effect, and emitted electrons is called it as photoelectrons. Now you know that electrons are negatively charged, which is emitted by the emitter, and collector plate is positively charged. Unlike charges or unlike plate attract each other, this emitted electrons will move towards this collector plate because the potential of the collector plate is positive. Since the potential of the collector plate is positive, this all the electrons move towards the collector plate. They move towards the collector plate. Since the potential of the collector is positive and electron is emitted by the emitter, they will move toward this side, and this will be the movement of electron. And you know that whichever will be the direction of electrons, opposite to that there will be direction of current. Since electron is moving in this direction, there will be photo current in opposite direction. Photoelectric current will be in opposite direction. We can measure this photoelectric current with an ammeter, which is microammeter, because this current is very small. Current is there, but the value of this current is very small. Therefore, we use a microammeter to measure it. See this electrons will be get collected, and electrons is moving in this direction, but the direction of photocurrent will be always opposite to the direction of electrons. Therefore, this will be in opposite direction. This will be the direction of photocurrent. Since electron is emitted, this electron is photoelectrons, the current which develops is basically called it as photocurrent or photoelectric current. Now, see this diagram. By this we are able to understand what is the phenomenon. Okay, over here. The thing is, the frequency of the radiation should be greater than suitable frequency. That suitable frequency is called threshold frequency. Above that, when there is a frequency, these electrons will be emitted. And initially, scientists do not know the dual nature of the light. Therefore, at that point of time, at the time of this experiment, they have noted down these observations, and later on they use this observation to prove dual nature of light. उस टाइम पे साइंटिस्ट को पता नहीं था ड्यूल नेचर ऑफ लाइट के बारे में, जब ये एक्सपेरिमेंट परफॉर्म हुआ था। एक्सपेरिमेंट परफॉर्म करने के बाद उन्होंने ऑब्जर्वेशन क्या क्या उनको पता चला वो नोट डाउन करके रखे, एंड देन दे डिस्कवर दैट अकॉर्डिंग टू दिस ऑब्जर्वेशन लाइट हैव ड्यूल नेचर, पार्टिकल नेचर एज वेल एज वेव नेचर. Then now we will get the current, and this is photoelectric current. Now see this glass transmitted only visible infrared red light but not UV light. Okay, therefore we have used a quartz which transmit UV light also. When a light of suitable frequency falls on a metallic cathode, photoelectrons are emitted. These photoelectrons are attracted towards the positive anode and hence photoelectric current is constituted. Observation from this experiment on photoelectric effect. The first observation, second, third and fourth. So we will see frequency of incident radiation. What will happen to frequency of the incident radiation? See this, there is a graph over here. When you increase the frequency of the radiation, there will be no photoelectric current. Means up to this point mu naught, there is no photoelectric effect, there is no photoelectric current. But when we get the suitable frequency, which is mu naught, after this there will be photoelectric effect and there will be increase in photoelectric current and it will increase like this. Variation of photoelectric current with frequency of incident radiation. It is observed that no photoelectric current is recorded till the frequency of incident radiation reach to a frequency which is suitable frequency is known as threshold frequency. This frequency depends on the material of emitter plate C. अब जो भी emitter plate C है, emitter plate को C क्यों बोलते हैं? क्योंकि this is basically a negative plate and negative one is called it as cathode. Therefore this is emitter plate is represented as C. तो ये emitter plate के ऊपर का एक suitable frequency जब threshold frequency मिलेगा तभी वो photoelectric effect start करेगा, मतलब इलेक्ट्रॉन जंप आउट होना स्टार्ट होगा. Therefore, for the initial stages, when the frequency is less than threshold frequency, there is no photoelectric effect, there is no photoelectric current. But as such, you got this frequency mu naught, threshold frequency, and you goes on increasing this frequency, the photoelectric current also increases, and then it becomes saturated or constant. Now, threshold frequency, the minimum frequency of incident radiation for which photoelectrons are just emitted from photosensitive material is called threshold frequency. This is the minimum frequency at which electrons are emitted or photoelectrons are emitted from photosensitive material. Okay, this minimum frequency is called threshold frequency. Okay, now you understood what is threshold frequency variation through this. Okay, now we see the next point. Intensity of incident radiation. Now, up till this point, we are concerned about frequency. You know that there are two characteristics of the electromagnetic waves. One is frequency, another one is wavelength. Frequency and wavelength are inversely proportional to each other. As frequency increases, wavelength decreases. Now, there is one more characteristic of light, that is intensity. What is mean by this intensity? Number of photon particles per unit area is basically the intensity of light. आप अगर एक रूम में हो और एक बल्ब ऑन है तो उस रूम का इंटेंसिटी समवॉट कम होगा. वैसे ही उस हॉल में अगर 2-3 बल्ब और लगा दो तो द इंटेंसिटी विल बी वेरी वेरी हाई. इंटेंसिटी इंक्रीज होगा जितना ज्यादा बल्ब्स आप वहां पे, दैट कैन बी अ CFL और LED बल्ब, आप जैसे इंक्रीज करेंगे उस रूम की इंटेंसिटी बढ़ेगी. इंटेंसिटी मींस नंबर ऑफ फोटोन पार्टिकल्स पर यूनिट एरिया, तो वहां पे इंटेंसिटी ज्यादा होगा. जैसे अगर आप बेसिकली देखो at afternoon when you move outside there is more intensity of light as compared to your room. इसलिए जब आप रूम से बाहर आते हो तो आपको एडजस्ट करने के लिए थोड़ा टाइम लगता है, पीपल को एडजस्ट होने में टाइम लगता है क्योंकि बाहर का इंटेंसिटी ज्यादा है, अंदर का कम है. तो इंटेंसिटी इज सेपरेट पैरामीटर. फ्रीक्वेंसी देख लिया आपने, अब हम इंटेंसिटी का कंसिडरेशन करें. इज इट ओके? इंटेंसिटी इज नंबर ऑफ फोटोन पार्टिकल्स पर यूनिट वॉल्यूम. मतलब आप देखो एक बल्ब के टाइम पे रूम का इंटेंसिटी, लाइट का इंटेंसिटी कम होता है, बट ज्यादा बल्ब हम जब लगाते हैं तो इंटेंसिटी हाई हो जाता है. It is found that photoelectric current increases linearly with intensity of the light as shown in the graph. See this. As we goes on increasing intensity of light, photoelectric current increases. But what is the condition for this? The condition is that the frequency should be, for this experiment or this observation, you should understand that the frequency should be greater than threshold frequency or equal to threshold frequency. Below that, there will be no photoelectric current. तो द थिंग इज, अगर हमारे पास रेडिएशन का फ्रीक्वेंसी नहीं है, थ्रेशोल्ड फ्रीक्वेंसी, तो आप कितना भी इंटेंसिटी बढ़ा दो लाइट का, देयर विल बी नो फोटो इलेक्ट्रिक इफेक्ट, देयर विल बी नो फोटो इलेक्ट्रिक करंट. बट अगर वो मिनिमम फ्रीक्वेंसी थ्रेशोल्ड का है, तो उसके बाद जब आप लाइट का इंटेंसिटी इंक्रीज कर रहे हो, तो उसके बाद फोटो इलेक्ट्रिक करंट भी बढ़ेगा एंड इट विल इंक्रीज लीनियरली. As intensity increases, photoelectric current also increases. See these two graphs. In frequency, current goes on increasing, but after some time it becomes constant. And in the case of intensity, as intensity goes on increasing, current also increases. And this I shown you in last lecture. In that we have seen that if we have a photosensitive material, and on that if we only increase the intensity, not the frequency, and frequency is less than threshold frequency, then there will be no photoelectric effect. Okay, see over here. See this, if photons are hit on this one, there are electrons are emitted, but this is greater than threshold frequency. See this, in this case what we are doing, we are increasing the intensity. See this, this is photons. Now I have increased the intensity, not the frequency. See this, instead of one photon particle, now there is 3 photon particles. There will be no electron emitted from this photosensitive material because the frequency of this radiation is less than threshold frequency. Then when the frequency is less than threshold frequency and you are increasing the intensity, there will be no photoelectric effect, there will be no photoelectrons, and there will be no photoelectric current. See this, now we have increased the intensity, but frequency is less than threshold frequency. There will be no electron is emitted. There is must condition for photoelectric effect is that the frequency should be greater than threshold frequency. Now, in this case, now what we are doing, see this, now we are providing the suitable frequency, that is threshold frequency of the light, and now we will increase the intensity. See this, 3 electrons are emitted, 3 photons are incident on the photosensitive material, 3 electrons are emitted. 3 photons, 3 electrons. Now what we are doing, we are increasing the intensity. Threshold frequency को हमने फिक्स कर दिया है अभी. अब हम सिर्फ क्या इंक्रीज कर रहे हैं, इंटेंसिटी को इंक्रीज कर रहे हैं. तो इंटेंसिटी को इंक्रीज करते ही क्या हो रहा है, there is increase in photoelectrons also. As the intensity increases, photoelectrons also increases, and this increases linearly, which we have seen in the graph. Sorry, which we have seen in the graph. But for that, the condition is the frequency of the radiation should be equal to or greater than threshold frequency. Now, see this in experiment. In the first case, which we have seen, if the source of light emit the radiation and hit to the emitter photosensitive plate, which is emitter, there will be no photoelectric effect until we get suitable frequency. And for that, we have to increase the frequency of the source of light. And when we get the suitable frequency or threshold frequency, then after it starts to emit electron, an electron will be moved towards the positive terminal, which is the collector plate, and we will get a photo current due to this photoelectrons. Since these electrons are negatively charged, they will be automatically attracted toward the positive plate. Okay, and now what we have to do after this threshold frequency, now we have to make the frequency constant above the threshold frequency, but now the frequency will be constant and we are increasing the intensity. And as we goes on increasing the intensity of the radiation, the photoelectric current also increases, and it increases linearly. See this. Over here, this is the graph for photoelectric current with frequency. It is increasing and then become constant. And when we see for intensity of incident radiation, it is increasing, but it is increasing linearly. Now you got these two things. This is implies that the number of photoelectron emitted per second is directly proportional to the intensity of incident radiation. मतलब जो इलेक्ट्रॉन इमिट होने वाले हैं वो इंटेंसिटी पे डिपेंडेंट है और फोटो इलेक्ट्रिक इफेक्ट फ्रीक्वेंसी पे डिपेंडेंट है. फोटो इलेक्ट्रिक इफेक्ट होने के लिए फ्रीक्वेंसी चाहिए, विदाउट फ्रीक्वेंसी फोटो इलेक्ट्रिक इफेक्ट नहीं होगा. बट आफ्टर दैट what is the thing? As intensity increases, photoelectrons also increases, and that increases linearly. Potential difference between the plates A and B. Now what we have to do after photoelectric effect? Now we have to make intensity as well as frequency constant. Now we have to make above threshold frequency, we have to make frequency constant and intensity constant. Now we will increase the potential between emitter and collector plate. ओके, पहले हमने क्या किया, फ्रीक्वेंसी एक एडजस्ट कर दिया है, थ्रेशोल्ड फ्रीक्वेंसी के ऊपर है, और उसके बाद हम क्या कर रहे हैं, करंट को चेंज कर रहे हैं. ठीक है, मतलब पोटेंशियल को इंक्रीज कर रहे हैं. तो एज फॉर I1 करंट, जैसे फ्रीक्वेंसी की एक x वैल्यू है, फॉर फ्रीक्वेंसी वी हैव अ वैल्यू x, वो फिक्स है थ्रू आउट. अब इस एक्टिविटी के लिए हमने करंट लिया y1, इफ यू हैव टेकन करंट y1, और I1 हमने करंट क्या लिया है I1, और हमारा फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी के अबव है, वो फिक्स है, दैट इज x. नाउ द थिंग इज we are increasing the potential between the plates, collector and emitter plate. Now what will happen, the current will increases and after some time it becomes constant. The current increases but after some time it becomes constant, which we have seen earlier also. Over here, as current I1 is fixed and frequency is x, which is above the threshold frequency. Now we are increasing the potential. Then what will happen? Current will increase and after some time it becomes constant. Okay, but now we have to study one more case. If suppose we change the potentials, we make collector as negative and emitter as positive, then what will happen, that we have to see, but we will see it later. The positive potential of plate A is gradually increased by keeping the frequency of incident radiation constant. Measure the resulting photoelectric current. It is found that photoelectric current increases with the increase in positive potential. तो जैसे हम पॉजिटिव पोटेंशियल बढ़ाएंगे, करंट भी बढ़ेगा. ठीक है, बट आफ्टर सम टाइम इट बिकम्स कांस्टेंट. ऐसा नहीं है कि आपने पोटेंशियल बढ़ाया और करंट भी सिर्फ बढ़ते ही जा रहा है, इंक्रीज होगा बट इट विल बिकम कांस्टेंट देन आफ्टर. Now give the negative potential to the plate. As we increase the negative potential of anode, the photoelectric current decreases. As a certain value of negative potential, the photoelectric current becomes zero. This negative potential is called stopping potential. Now see, for this we have to see this diagram. Now over here in the second case, for the same thing, what we are doing, we are increasing the negative potential of this anode. अब हमने इसको पॉजिटिव के जगह नेगेटिव बना दिया. तो अगर नेगेटिव बन गया और इलेक्ट्रॉन भी नेगेटिवली चार्ज है तो देयर विल बी रिपल्शन बिटवीन दीज टू, देयर विल बी रिपल्शन बिटवीन एनोड एंड इलेक्ट्रॉन। तो जैसे ही एनोड के ऊपर रिपल्शन आएगा और आप नेगेटिव पोटेंशियल एनोड का बढ़ाते जा रहे हो तो इलेक्ट्रॉन वहां पे हिट नहीं करेंगे, रुकने लगेंगे, जिससे क्या होगा, फोटो इलेक्ट्रिक करंट कम होने लगेगा। बट जो इलेक्ट्रॉन बहुत फास्ट है वो तो जाके हिट करेंगे एनोड को, वो रुक नहीं पाएंगे ड्यू टू इट्स इनर्शिया। द इलेक्ट्रॉन विल हिट टू दिस प्लेट बट करंट विल स्टार्ट टू डिक्रीज। अब इसमें से जो मैक्सिमम स्पीड वाला इलेक्ट्रॉन भी स्टॉप हो जाएगा एक हैवी पोटेंशियल पे। अगर इसका आपने एनोड का नेगेटिव पोटेंशियल बहुत हाई कर दिया तो उस टाइम पे ये इलेक्ट्रॉन वहीं पे स्टॉप हो जाएगा। दिस पोटेंशियल इज कॉल्ड इट एज स्टॉपिंग पोटेंशियल, क्योंकि इलेक्ट्रॉन नेगेटिवली चार्ज है। आप अब एनोड को क्या कर रहे हो, कलेक्टर प्लेट को नेगेटिव पोटेंशियल प्रोवाइड कर रहे हो विद द हेल्प ऑफ कम्यूटेटर। तो पहले जो स्लो इलेक्ट्रॉन्स है वो तो रुक जाएंगे, जिसकी वजह से फोटो इलेक्ट्रिक करंट कम होगा, बट जो मैक्सिमम स्पीड वाला है वो तो हिट ही कर रहा है ना। तो एट अ सर्टेन पॉइंट व्हेन यू आर इंक्रीजिंग द नेगेटिव पोटेंशियल ऑफ द collector plate, at that point where all the electrons are get stopped, जिसका सबसे मैक्सिमम काइनेटिक एनर्जी है वो भी अगर स्टॉप हो जाता है, वो हिट नहीं करता है उसपे, तो दैट नेगेटिव पोटेंशियल ऑफ द कलेक्टर प्लेट विल बी कॉल्ड इट एज स्टॉपिंग पोटेंशियल, दैट विल बी कॉल्ड इट एज स्टॉपिंग पोटेंशियल। Now see over here the potential difference between the plates A and C, यहाँ जो है वो हमने क्या किया, नेगेटिव किया। तो नेगेटिव करने के बाद क्या हो रहा है, देखो इट गोज ऑन डिक्रीजिंग एंड इट स्टॉप्स। अब हम सेकंड, ये केस 1 हो गया, केस 2 में फिर अब क्या करेंगे, करंट की वैल्यू थ्रेशोल्ड फ्रीक्वेंसी XC है, I2 रखेंगे और फिर उसके बाद देखेंगे कि जब हम पोटेंशियल को बढ़ा रहे हैं तो करंट क्या हो रहा है, इंक्रीज हो रहा है सेकंड केस में भी। तो as we increase the anode potential, current increases, then it becomes constant. But see over here on the left hand side, stopping potential is same. Stopping potential is same. For all three cases, the current is increasing as we increasing the anode potential. But stopping potential is constant. Then by this, what can you say? The stopping potential is independent of this potential which we have seen. The minimum negative potential V naught given to a plate A for which photoelectric current stops or becomes zero is called it as stopping potential. Okay, and after this we will see the other observation, but that we will see in next lecture. If you have any doubt regarding this topic, you can ask us on WhatsApp groups. And we will do the remaining part in next lecture. Before that, you have to read this topic. If you read this topic, it will be easier for you to understand this topic. Okay? Thank you.